tackling, what we should be covering. So this is about the concept of integration and application. So first, we will learn techniques on how to solve individual integrals of different variables, and later in this course we will be using those techniques, how to solve those equations to physical problems, such as this evaluation of areas, volumes of revolution, force, and work. So fundamental formulas and various techniques of integration applied to both single and multivariable, as well as tracing of functions of two variables. So again, you're already informed, the course prerequisite is Engineering Calculus 1, and that's differential calculus. It's not the only thing that you need to know, because you know that in Engineering Calculus 1 you also have prerequisites. You need algebra, you need trigonometry, you need geometry, and other basic engineering mathematics. So for this meeting, these are our target outcomes. So at the end of this meeting, you should learn to execute this new learnings. So the first one would be to express Calculus 1 differentiation rules as anti-differentiation rules. So that means that you shouldn't forget yung mga theorems and rules and yung techniques na natutunan nyo sa Engineering Calculus 1 or Differential Calculus, so that you can inverse that and you can perform integration. And also, number 2, apply these integration rules and appropriate substitutions to calculate indefinite integrals. So right now, we will be dealing with indefinite integrals. So later in the course, in the next lectures natin, we will be also dealing with definite integrals. Yun ay yung from an lower bound to an upper bound. But for this for today, as this is day 1, this is lesson 1, module 1, we will just be dealing with indefinite integrals. Number 3, okay, evaluate an indefinite integral using simple power formula and simple trigonometric functions. So in differential calculus, I know you learned about also the simple power formula for differentiation. So maybe you have an idea now. We just need to reverse that theorem in order to get the simple power formula for evaluating indefinite integrals. And also, if the time allows, we will go into simple trigonometric functions. So in differentiation, I believe you also discussed or studied yung theorem for evaluating or differentiating yung simple trigonometric. So the same goes for it. We'll just reverse those theorems. Is that okay? Any questions about the outcomes that we are targeting for today's meeting? Okay, nobody's responding, so I will continue. Okay, so now let's go to what is anti-differentiation or integration. So this is the process of finding the set of all the anti-derivatives of a given function, and it is denoted by the symbol this. It's like a letter, an elongated capital letter S, which stands for it actually is for sum. So this integral sign is divided from, if you can picture out, hindi ko lang maisulat dito sa ngayon yung summation sign. Natatandaan nyo ba yun? It's like nakatagilid na letter M. So that is the Greek symbol denoting sum. This one is the Roman counterpart of that. So whenever you see that symbol, I hope until the end of this course, you will not learn to fear this symbol. Pag nakikita niyo, I hope it won't give you nightmares seeing this symbol. Alright. So the fundamental idea would be, if you have a function which is denoted by f of x, and the derivative of that function, this would be the derivative of the function f of x, and if you put the integral sign in front of it, it just basically cancels the differential operation. So if you see this, integrate a differential, so that should be equal to only the function, alright, plus the constant of integration. Okay, so for now, for this first or the basic idea of integration, do you have anything you want to ask or you want to clarify? Anyone? Or are we still good so far? Okay. So this is the fundamental in equation form. So the integration of the derivative of f of x would just be equal to f of x plus a constant of integration. So we are dealing right now with indefinite. Remember, we are dealing right now with indefinite integration. So we will always have this constant of integration. So when we arrive at definite integrals, wala na itong constant of integration na ito pagdating dun. Okay, so theorems. So before I go to theorems, I just want to give you some what do you call this? Some idea about the relationship and some applications nitong integration. So I believe you are taking physics right now, right? Is that correct? You have a physics subject right now?
Yes.
All right. So in physics, we have you will discuss about Newton's laws. So this is physics. So particularly Isaac Newton's second law. Can anyone tell me what is Newton's second law? Anyone? No. All right. That's not a problem. Maybe wala pa kayo dun sa physics nyo. But Newton's second law is saying that the force can be computed by multiplying the mass and the acceleration of a body. So acceleration, I'm not sure if you already learned this in your differential calculus. Who can tell me what is the relationship between acceleration and velocity? Anyone? Anyone wants to tell me? Yes, hindi ko nakikita kung sino yun, but okay, just open your mic. Hindi kita makita. Sorry.
Sir, acceleration is the rate of change of the velocity over time, sir.
Rate of change of the velocity over time. Okay, so if I write that as a differential, thank you for that. I'm sorry, I cannot see you. What's your name?
Abdulhaq, sir.
Okay, thank you. Okay, so if we write that as a differential, so that is actually the rate of change of the velocity, or dv, over the rate of change of time. Correct? Okay. So this is a differential. If we are given the function of the velocity, how can we then solve for the acceleration? So as you know, we can solve this equation by putting an integral sign here and evaluating the function. And also we know that, can anyone tell me what is dito ko na lang sulat. Okay. What is velocity? Anyone can tell me? Just
Derivative of
are you the same person?
yes sir, sorry sir.
Okay, no problem. Just tell me what is.
It is the rate of change of the position over the time, sir.
Okay, so for this one, let's just use for the length or the distance. Let's just use r. Okay, Ben. So that would be r. The change in length or change in distance over the change in time. Alright, so now if we are given a function for the distance traveled with respect to time, how can we compute the velocity then? We again use integration. So we will put an integral sign here and we will solve for the velocity. So you can imagine if I put if I give you the equation or the function for the distance, and I ask you to compute for the acceleration, so what will you do? How many times will you integrate the function? How many times?
Can you repeat the question, sir?
If I give you the equation for the distance, I will give you dr dt. How many? If I ask you to compute for the acceleration, how many times will you integrate?
Twice.
Okay, you will integrate twice. So that is yung tinatawag natin na double integrals, double integration. So we can simply put that the acceleration of a body would be, you need to just let me write it this way. So this would be the second derivative of the distance over dt squared. So this would be your equation for acceleration. So you need to integrate this equation twice in order to get the acceleration. So pardon yung mga inconsistency ng linya. Medyo mahirap mag-drawing gamit ang mouse. Okay, so far any questions about this? You really don't need to understand this one at this point. We will be discussing it in the applications din naman. I just want to give you an idea where for some applications of integral calculus yung matututunan nyo, since mas masaya aralin yung isang bagay kung alam mo kung saan mo siya gagamitin, tama ba? So ayun, any questions so far? Can I go back now to my slides? Any questions? No? Okay, thank you. Now let's go to the theorems. So now because anti-differentiation is inverse, the inverse of differentiation, the theorems for anti-differentiations are also obtained from those on differentiation. So babalik na rin lang natin yung mga theorem na natutunan natin doon. So now, the first theorem that we have would be it's the same thing as the first equation na pinakita ko sa inyo. It just change yung yung variable, which is u. So the integral of the derivative of u must be just equal to u plus the constant of integration. And we have theorem 2. So we have this equation that the function u du should be equal to a outside of the integral sign and the function u du. This is where a is a constant. Okay? So, we will just, kapag nakita kayo ng function na may constant, before you integrate it, you put that constant outside of the integral sign and then proceed to integrate the function with respect to integrate the function. In this case, that's the function of u du. Okay ba tayo dun so far? So these are just very fundamental. I believe you already encountered this in differential. Right now, binabaliktad lang natin yung sagot nyo dun sa sa differential calculus. Yun ang tanong ngayon dito sa integral calculus. Okay. Can I proceed? Okay, thanks. It's really hard not to see the reactions sa mga mukha kasi nga hindi ko alam kung kayo ba ay nako-confused na or kayo ay okay pa. So I hope the silence means that you are still okay. So theorem number 3. So if we have two functions separated by operators, either addition, subtraction, that's just subtraction and addition lang pala, two functions, f of x plus g of x dx, what happened here? We just distributed yung integral sign natin. So, we integrate them separately kapag they are separated by this plus sign. So, we treat them as individual integrals. So, you can imagine this answer would have its own constant of integration and this one will also have its own constant of integration. So, that would be c sub 1 and c sub 2. But if you add both of those, since they are both unknowns, but we know that they exist, we can just collectively put them in the end of our answer as plus c. Okay? Is that clear?
Clear.
Okay, thank you for that response. So now let's go to theorem number 4. Okay, so this one is about an n number of functions separated by plus and minus sign with constants of their own. So this one, c sub 1 f sub 1 x plus c sub 2 f until c sub n f sub n x dx. So we integrate that as the same thing. So we will just separate each one. It's like this theorem number 4 is just the combination of theorem number 2 and theorem number 3 where inilabas natin yung constant and we treat each expression doon, ito c1 f1 x dx as an individual functions to integrate. Okay, so I'll give you maybe a minute to process all of this. Don't hesitate to ask questions, to clarify things before we proceed dun sa sample problems. Okay, someone's raising his hand. You have a question?
Yes, sir.
Yes.
Only one question pa, sir.
Yes.
Sinadya po talaga na i-separate yung sa subtraction, sir, na theorem, sir. Or the same lang po yung from properties po, sir.
Okay. As I've said, this one, if you can use this either for addition or subtraction, as long as they are separated by a plus sign or a minus sign. Okay, so it doesn't matter. Or
Theorem 4, sir.
yes.
Included pong theorem 4 dun, sir.
Yes.
Pwede po siya.
Yes, I just use this plus sign kasi imagine these constants are integers, right? So you will have maybe the value for your c sub 2 will be negative 5. Let's say negative 5. So that would just be the same as plus negative 5. Or if you want, that would be minus kaagad. And then minus and positive 5 and multiplied by the function. Okay?
Thank you po.
Okay, thank you for that question. So, I'm sorry, hindi ko na nalagyan ng time, nalagyan siya ng plus or minus dito, but I hope you get the idea that we will be dealing with positive and negative numbers here. So, use yung mga properties sa pag-add, sa pag-subtract ng mga functions na natutunan nyo na rin dun sa mga lower math nyo. Okay, any more questions before we proceed? No? Okay. So we started 9:15. Okay, every hour we will take a break. We still have one more theorem for now. Okay, so this theorem number 5 would be, okay, so looks like I committed a mistake here. Let me this should be du. Okay, this is not dx. So if nag-take notes kayo, pakilagay na lang siya na du. Okay, so the integral of u raised to the power n du should be equal to u raised to the power n plus 1 all over n plus 1. The same power that you increase by 1 is your you divide the function with that n plus 1. And also don't forget your constant of integration plus c. Any questions so far about this? Does this satisfy? Yes?
Sir, yung po bang n plus 1 po ay laging lagi pong siya po yung pinaka-constant dyan or nababago po din siya?
Can you repeat the question? Medyo hindi ko naintindihan kung ano yung tinatanong mo.
Kung po sa namabago po ba yung n plus 1 na yan?
Nababago? What do you mean nababago?
Halimbawa po, yung pong n plus 2 ganun.
No. This is your general equation. This is actually yung simple power formula for integration. If you can recall. All right. To answer the question, ang magbabago lang dito ay yung n. Okay? So it may be u to the second power, u to the third, but the theorem or the law is that you increase whatever the value of n by a power of 1. Okay? Is that understood?
Okay, sir. Thank you po.
Okay, thank you for that. And by the way, there's some restrictions. Your n okay, this is another mistake. I'm sorry. So this should be not equal to negative 1. Okay? So if you are listening, please, I will edit this stuff later before I upload it on our classroom. So this would be n should not be equal to negative 1. Okay? Any question concerning that?
Yes sir, may question po.
Yes.
So different po yung para sa mga para po sa denominator po ng power like 1 over un, parang ganyan po. Since maging u to the power of negative n po yan.
Not necessarily 1 over u to the power of n. It's just u to the negative 1. 1 over...
Okay.
Since you can have n like negative 2, negative 3, or whatsoever. Just not negative 1.
Ano po yung special rule para dito, sir?
Okay.
If negative 1 po siya.
I'm glad you asked. So the next theorem would be concerning that. Okay? So if we have this u raised to the power of negative 1, that would just be the same as saying 1 over u. Tama ba? So that's 1 over u multiplied by, again, this is not dx, this is du. So that would be du over u. So that theorem is a totally different one, which is the integral of that du over u. So if the derivative is in the numerator and the function is in the denominator, the answer would just be equal to ln of the function plus the constant of integration. Okay, so how many theorems so far? We already have some 6 theorems. So any questions before we proceed to the examples? Any questions for these theorems?
Ano po, sir?
None? Okay. So I hope you familiarize yourself with these theorems, and maybe you can write it down for now. Take notes so that sa mga succeeding na mga problem solving natin ay ma-select nyo kung ano yung suitable na theorem na i-apply. Okay, so now let's go to, if you don't have questions so far doon sa discussion, let's have some sample problems. Okay, so we have here in the integral sign and enclosed in parentheses the function 5x to the 4th power minus 8x cubed plus 9x squared minus 2x plus 7 close parentheses and dx. So we learned some theorems before, and we should be applying those theorems to evaluate this integral. Okay, so if you can also solve this, and if you have a pen and paper there, and just check if you will also arrive with the correct answer. So let me transfer now to my whiteboard. Saan na ba yung whiteboard? Okay, so is this the same? We have the function 5x to the 4th power minus 8x cubed plus 9x squared minus 2x plus 7 dx. So we want to integrate that function. So theorem number, anong theorem ba ito? Theorem number 3, I guess, says that we should treat each expression as a separate integral and integrate accordingly. So now let's start with the first function, which is 5x to the 4th. So that would be the integral of 5x to the 4th power dx. That's our first expression. Okay, so do you want me to solve it while discussing, or do you want to be involved in the solving? Any way is okay for me. Okay, so I will just proceed. So what theorem do we need to apply next? Since we have this expression 5x to the 4th power, can we directly use yung theorem number 5 natin, which is yung simple power formula? So Theorem 2. So Theorem 2 states that if you have a constant, you put it outside of the integral sign. So you have 5 outside of the integral sign, and you have x to the 4th power dx. So the integral, the function inside the integral sign pretty much looks like yung ating power formula. Which says that power formula. Tagal magsulat dito. Okay. So the power formula says the integral of u raised to a power n du would just be equal to that function u raised to n with the exponent increased by 1 divided by the same exponent increased by 1 plus the constant of integration. Okay. So I hope you realize that the power formula that we presented for integration is just the reverse of the power formula for differentiation, where you multiply the function with the exponent and you decrease it by 1. So this one you increase it by 1 and you divide it by the exponent plus 1. Alright, so since our function inside the integration operation or integral sign is somehow looking like this, so we just need to do the substitutions. So we have, the answer would be, it should be equal to 5 multiplied by x. What would be the power now? It should be 4 plus 1, that would be 5. And it must be divided by n plus 1, 4 plus 1, that would also be 5 plus the constant of integration. Since we are dealing with 1, 2, 3, 4, 5 expressions, we will just put this as C1. Okay. Okay, so for the first one, this will cancel out. And we will be left with x to the 5th power plus 5 C1. Or, if you want, since this is an unknown constant multiplied by 5, we can just say this to be, okay, C1. Okay, so for our, to answer this question, let's just put it here underneath. I hope you can still see it on your screens. So this would be x to the 5th. So mamaya ako na ilalagay yung mga constant of integration. So that is for the first one. So any questions so far sa ating unang expression na in-evaluate using the simple power formula? Are we good? Can I erase this?
Yes.
Okay, we're good. So let me erase this and proceed to our next. So pretty much we will be following the same steps in evaluating this problem, since you can see all the expressions have a constant and they are raised to a certain power. Okay, so next up is negative 8x at 8x cubed. So the same thing we will do. Apply theorem number 2. We put the constant out of the integral sign. And we have x cubed. Sorry, meron palang dx dito. We have x cubed dx to evaluate, which also follows yung ating simple power formula. So this should be equal to negative 8 multiplied by x. That would be 3. N plus 1. 3 plus 1, that would be 4. All over n plus 1, which is also 4. Plus our constant of integration, let's call it c sub 2. Okay, so as you can see, for the first one, this one will cancel out. This would just be negative 2 and this will cancel. So we are left with, we have negative 2 x to the 4th power plus, I would write negative 8c2, but then again, that's just a constant, so let's just say it's c sub 2. And this is the answer for the second one. So I think maybe for some of you, we are going very slow, but again, we should be emphasizing the fundamentals here. So if you are as much as I want to fast forward it, it's really makes me slow to write using yung mouse lang. Okay, so far everyone is following, everyone is recognizing the pattern using the power formula and applying it. We have no problem for that with that. Anyone? Do you have any questions you want to clarify? No? Alright. So, now let's go to... So, dito sa baba, dito ko sinusulat yung mga sagot. Okay? Since yung i-add natin lahat ng ito. Para dun sa, para sa sagot. Now, the next one is 9x squared. So, maybe dyan sa mga papel nyo, tapos na kayo siguro mag-solve. Okay lang yun, walang problema. Medyo bumabagal yung response ng mouse. Sorry about that. I will try to acquire some useful gadgets para mas madali itong pagsulat dito. Okay, so now we have 9x squared dx. So far naintindihan nyo naman kung bakit natin siya ini-integrate isa-isa. That's theorem number 3, right? So it's just basically we distribute yung integral sign and yung dx. We multiply 5x to the 4th power by dx, negative x cubed by dx. That's why nagkaroon tayo nitong mga individual integrals na ito. So same, put the constant outside of the integral sign and integrate what remains. So that would be x squared dx. So this is a very basic. You can do it even nakapikit. So this should be 9 multiplied by x raised to 2 plus 1. That would be x cubed divided by n plus 1, 3 plus the constant of integration sub 3. And this one will cancel out. This would be 3. This would be 1. So we are left with 3x cubed plus the constant of integration 9c3, or let's just simply put it as c3. Okay. So this is our answer for the third expression. So I'll just write this down as plus 3 x cubed. So hindi ko muna sinasama dito yung mga constant integration. Yung ating C1, C2, C3 mamaya pwede nating pagsamasamahin yan into just C, constant of integration. Okay, can I erase? Okay. Thank you. So just enjoy this time. Kung medyo nababagalan pa kayo, sa mga susunod siguro magdadasal na kayo na mas bagalan ko pa sa mga susunod na mga lessons natin. So this one is, since we are just in day 1, we are building yung solving technique natin and yung fundamentals pa lang natin. Kaya ganito pa tayo ka slow start. But huwag kayong mag-alala, dadating din tayo sa punto na medyo mabilis na yung mga bagay-bagay na kukurap ka lang is may iwan ka na. Okay, next expression would be negative 2x dx. So the same thing, ilabas ang constant, i-integrate ang naiwan sa loob, which is x dx. So I hope everyone can just imagine this as this is x raised to the first power. So our answer should be x n plus 1, that would be 1 plus 1, or x squared, and our denominator would be n plus 1, also 2, plus our constant of integration c sub 4. So obviously this one will cancel out, so this would just be negative x squared plus negative 2c sub 4, or simply just put it c sub 4. And okay, we're now down to the last expression to integrate. So that would be x, this would be negative x squared. Okay, I will erase this one. And our last expression would be 7 dx. So what will happen here? We have a constant that should be integrated with respect to a variable that is not in the function. So if we integrate 7 with respect to x, we don't have any x, right? Wala tayong x. So how can we integrate this constant? Anyone has an idea how to proceed with this? So our integral would be 7 dx. So are we supposed to use another theorem? Since, do you see any pattern here? Can we use power formula here?
Pwede po, sir.
How?
The exponent of x is just 0, sir.
Okay.
It appears to
So
be
since
1.
we are asked to integrate this constant, this function na wala namang x sa kanya, with respect to dx, we will just see it as the integral of 7 times 1, which is x raised to the 0 power. So anything raised to 0 is 1. Tama? Dx. So now we can see that we can still use the power formula for this one. So theorem 2, ilabas yung constant and then integrate x to the 0 power dx, which gives us 7 multiplied by, this would be x plus 1. So meron lang tayong x divided by 1 plus our constant of integration c sub 5. So the answer would be 7x c sub plus c sub 5. Okay, so we put this here, this answer here, that would be 7x. And yung kanina na meron tayong, for this one, we have C1, C2, C3, C4, C5, and we add them together and we just put it as a constant of integration, C. Okay, so this would be sagot natin dun sa integral na ating in-evaluate. Okay, any questions? Everyone followed? Everyone did it on paper and arrived on the same answer? Anyone who's got a different answer, can you share with us so that we can see if meron tayong na-miss na step, meron ba tayong mali, or are we all on the same page? Questions? No? Okay, I thought so. Since this one is a very easy example. Mahaba lang yung solution, but it's very easy. Okay, now let's go to another example. Yes? Is there any question? So we have this equation. Tama ba yung pagkasulat dun? Okay. We have the square root of x multiplied by in parentheses x plus 1 over x dx. We need to evaluate this one. Okay, so what do you think shall we do? Can we still use the power equation here? Let me see, pwede ba ako mag-copy? Hindi ata ako pwede mag-copy dito. So, okay. So, what we need to do is just perform the operation first so that we will see if we can see any pattern. So, for this one, this is the square root of x. This is just equivalent to saying that x is raised to the power 1/2. Right? Square root of x is just equal to, and we multiply it by x. This is x raised to the first power. Tama ba? Or if you want to easily visualize it, let's put it as x to the first power, or x2 over 2. Plus, this is 1 over x. This is in, let's put it as a fraction. So this would just be equal to x to the negative 1 or negative 2 over 2. Is everyone following yung ating transformation na ginagawa? We just simply express the exponents as a fraction having the same denominators para mas madali yung pag-operate natin. Since we know that we have this expression in parentheses and there is an expression outside of it, we need to multiply it by distributive. We distribute it, x to the 1/2 multiplied by x to the first power, or 2 over 2, and in the operations with exponent, we need to add the exponents. Okay? So now we multiply x to the 1/2 by x to the 1, or x to the 2 over 2. That would give us x to the anong mangyayari sa kanya? This would be x to the, you add the exponents. Is that right? Multiplying variable, the same variables, and getting the exponents. Is everyone following? Okay.
Yes, sir.
It's really hard to know if you are confused already, or is this easy. I would like to think that this is easy for you. Okay. And the other one would be, that would be x. Add the exponents, that would be 1 minus 2, that would be negative 1 over 2. And don't forget that we still have dx. Okay, so now that we transformed it into a more familiar form where we can apply our theorems, so let's distribute this dx to this one. So we need to solve the equation of the integral of x to the 3/2 dx plus, okay, as individual integrals. And ayoko na isulat yung power formula dito. I hope na sa ulo nyo na siya. Medyo mahirap magsulat. Or balikan ko na lang. Ito, yung power formula natin. U to the n du is equal to u plus n plus 1 over n plus 1. So now, we perform the integration. So in this case, we would be having, so what's this? We would be having x for the first one. Okay, dito ko lang isulat sa baba. Since wala namang mga constant, wala tayong ilalabas. So this would be 3/2 plus 2 over 2. That would be 5 over 2 And the same 5 over 2, we will divide it by 5 over 2, or simply this will become 2x to the 5 halves power all over 5 plus constant of integration c sub 1. Let's say c sub 1. Okay, so that's for the first one. So I will write it somewhere here. Okay, 2x to the 5 halves all over 5 plus c1. Okay, for the next integral, still we will be doing the power formula. We have x negative 1 half increased by 1, or 2 over 2, that would be negative 1 plus 2, that would be positive 1 over 2, divided by 1, same thing, 1 over 2. Or simply put, that would just be 2x to the 1 half plus c sub 2. Okay, so I will write this down here. So they are separated by a plus sign. So plus 2 I would prefer to put it in square root notation, but just so you won't be confused, just put it 2x to the 1 half plus, that would be c1 plus c2, or just c. Okay, any questions so far with this example? So let me finish all the dalawang example na lang din to before we take a break. So do you have any questions? Is it clear? So as you know already, you can just see the function and then directly perform the integration. Sometimes you need to do the transformations for you to easily transform yung function into something na pwede nating i-apply yung ating mga natutunan na theorems. Mga natutunan natin na theorems so far pa lang naman. Okay? So I believe this is still very easy, so I'm not surprised na walang nagtatanong. So now let's proceed to another example. We have, okay, so now palitan muna natin yung x, palitan natin siya ng t. We have this problem, 5t squared plus 7 all over t to the 4/3 with respect to dt. So now, okay, tama ba? This is 5t squared plus 7 over t to the 4/3. Okay, so now, what should we do with this one? Have we learned any pattern yet to solve this one? So the same as the example before, we also need to transform this into separate integrals by separating the fractions. So we have 5t squared all over t to the 4/3 plus, it is separated by a plus sign, the integral of 7 all over t to the 4/3. Sorry, we have here a dt pala. Let me erase that. We have here dt since we sineparate natin sila at distribute natin yung integral sign at yung dt. So they both should have dt. Okay. So what theorem should we be applying for this one? Again, we have theorem 2. So we will for the first one, ilabas muna natin yung ating constant which is 5, and yung natitirang integral would be t squared all over t to the 4/3. So performing operations on this exponents, so we can say that 2 is just equal to t to the 6/3 all over t to the 4/3. So since we are dividing, we will be subtracting yung exponents. So that would be 6/3 minus 4/3. That would be, this will be equal to t raised to the power of 2/3. I'm sorry, medyo nawawala yung aking dt. Kailangan palang laging mayroong dt dito. So huwag nyo wawalain yung dt habang hindi nyo pa na-evaluate yung integral. Okay, so now we can use a power formula here since this is t raised to the 2/3. So we have, the answer should be equal to 5 multiplied by t raised to 2/3 plus 1, which is 3/3. That would be 5 over 3 all over 5/3. So this one cancels out. The 5 will cancel out and the 3 would remain. So the answer should be 3t raised to 5/3 plus C1. Does everyone follow? I hope there is no confusion kahit napalitan natin ng U, palitan natin ng V, palitan natin ng T, palitan natin ng A, no. So as you I think you already realized now kanina sa ating example dun sa Newton's law, you are using velocity V, you are using R for the distance, you're using A for the acceleration. So I hope wala nang confusion kapag pinalitan natin yung X, pinalitan natin yung Y. Okay, so proceeding, we have another integral where pwede nating ilabas yung constant na 7, and this would just be, the remaining integral would be t to the 4/3, or we can just put it as negative 4/3, t to the negative 4/3, instead of writing 1 over t to the 4/3 dt. Medyo mahirap na siya sumulat. Okay, dt. Alright, so this one we can perform the power formula here. So we have 7 multiplied by t to the negative 4/3 plus 1, which is 3/3. So that's negative 4 plus 3. That would be negative 1/3. 7t to the negative 1/3 divided by 1/3. So 1 and 3 plus the constant of integration, of course, let's call it c sub 2. So now the 3 aangat yung 3. So we will multiply it by 7. So we have negative 3 times 7 is negative 21 t to the negative 1/3, or at this point we can write it as all over t to the 1/3, or the cube root of t. Okay, so let me write the answer here. So the answer is minus 3t to the 5/3 minus 21 all over t, the cube root of t, or t to the 1/3, plus the constants of integration, which is c1 plus c2, or simply c. Okay, so this is our answer for this one. Any questions so far? I hope everyone is following good. Please don't hesitate to ask questions. We are still building and teaching you the techniques here. So, walang problema kung mayroon pang mga confusion. We are here, kaya nga tayo nag-conduct ng online lecture para ma-address yung mga confusion na yun. No? No questions? So, let me add another blank space to work on. And next example would be this. I think this is the last one for this part. X squared plus 1 over x dx. Let me just write that down. So the problem is x squared plus 1 over x dx. Okay, so for this one, we just need to separate x squared plus 1 into separate fractions. So we have the integral x squared over x dx plus the integral 1 over x dx. So this looks like an easy one. So this will cancel out since may x din dito sa baba. So it will be equal to just what happened? The integral of x dx. So that looks very easy now. Plus this is the integral dx times 1, that would be dx over x. Okay, it looks easier, right? So this one we can just use the simple power formula. So we have x to the 1 plus 1, that would be x squared, all over 1 plus 1 over 2, plus the constant of integration c sub 1, plus what's this pattern? This is basically du over u, which we learned earlier. That is what theorem again? That's theorem number 6. It says that this is equal to ln u plus c. So the answer should be ln x plus c sub 2. So we write it down as, we combine the constants. We have x squared over 2 plus ln x plus c. So the answer to this integral would be this one. Any questions so far? Are we good? Did you follow all the examples? Did you arrive at the
Yes, sir.
same answers? Okay, that's
Yes,
very
sir.
good. Any questions? Okay, so if we don't have questions for now, let's take some 10 minutes break. Let's take a 10 minutes break. Let's come back at 10:35 na lang tayo bumalik. Okay ba yun? Or if you have questions after the break, it's no problem. Let's come back at 10:35. Alright? Is that okay?
Okay.
Yes, sir.
Okay.